morning, team. As Sunil has set up the baseline to understanding the mass spectrometry and especially with respect to high resolution mass spectrometry. So, what is the importance of the high resolution mass spectrometry in our day-to-day analysis as well as some research or any academic project you wanted to work? How it is playing important role to reach out your exact objective in terms of the identification of your correct molecule and their confirmatory criteria. So I will just go through that few of the applications. So based upon that, if you have any questions, I can happy to answer your queries also. So I will talk about that by using the GC-HRMS, specifically persistent organic pollutants or any contaminants, I can say, and then followed by food authenticity point of view, how we can leverage this HRMS technology to give their proper justification in terms of the identification of food fraud or any food purity. In that aspect we can see. So when we are talking about the basically persistent organic pollutants, these are the very stable chemicals available in the nature and which are very difficult to degrade in the presence of environmental conditions. So that's why we are considering as a persistent organic pollutants. And I just selected here few class of compound. There are a variety of class of compounds are available which can be considered as a persistent organic pollutants. So out of that I just selected PAHPCB as a case study point of view. How that can be analyzed by having the GC-HRMS and what is the confidence level we are keeping to say that yes, these persistent organic chemicals or persistent organic pollutants are present in my samples, and how we are going to justify our results. So when we are talking about that, basically PAHPCBs and their related derivatives are there, and these are maybe list depending upon the regulatory requirements. So which regulation you are following for completing your analysis. So either EU regulation, UK, US based, China based or Indian regulations. So based upon that regulatory requirement, your list may be varied as well as your permissible limits also may change. But thing is that here identification and confirmation criteria will remain same as well as your quantitative criteria will remain same, irrespective of their permissible limits. So based upon your regulatory requirement, you need to set your limit of quantitation in terms of the identification and confirmation followed by quantitative approach. So why GC-HRMS has been considered here as the best solution? When we are talking about the analytical challenges, what are those challenges considered for such type of the chemicals? Because these chemicals are very thermally stable and they are not easily wash out also. So that's why we need to see that what type of over extraction conditions needs to be followed, what kind of the analytical approach we should follow to get that accurate and precise results. That is very important aspect. So when you are considering that, basically challenges, the list of that molecules, POP molecules are there. It's a very much diverse because today you are monitoring maybe 10 to 12 or 15 compound. Tomorrow it may be increased, maybe 60 to 100 also. Because day by day their derivatives also inclusion happens and we are not sure about that whether the derivatives has been already somebody has reported or you are first time reporting that. Because that's why this POPs analysis becomes very important nowadays, and that's why HRMS plays very much important role where you can do that as an untargeted analysis also through retrospective approach. Because here in case of triple column, when you are doing the analysis, you are doing the 100, 200 or 500 or maybe 15 molecules as a target based approach, and once you did that analysis, that activity finish. But in same sample preparation approach, when you are acquiring the data by using HRMS, where you can do that targeted reporting first, then you have another possibility as a retrospective analysis by having the HRMS techniques. You can research in the same acquired data for the another other untargeted or non-target approach analysis, where you can try to find out their hidden impurities, hidden metabolites, which are not a part of your target list. So that is best approach through the HRMS you can easily achieve. Then basically as a part of this mixed culture analysis, so basically you need to report as a parent compound as well as their, in certain cases you need to report their metabolites also. So when you are doing the parent compound analysis, metabolites, those are not stable or they are having some challenges with respect to analytical, with respect to sample preparation approach. So those uncertainties also you need to consider when you are targeting this method is perfectly fit for purpose. So in that case you need to see that what is the capacity of your method, how many molecules, how many analytes are there, including parent and metabolites, you are confidently reporting as per any performance criteria. That is also very much important, as you have seen that Sunil has presented some slide where he has shown that comparison of triple chord or single chord data versus HRMS, how the data looks like a precise. That is also very important, where you are having the high level of filtration of your background noise because of the high resolving power, then your identification accuracy is much clear and accurate. That is very important aspect. Second thing, when you are developing any method or any solution or any workflow, you should see that what is the competitive status of that solution. Whether I am developing any solution or any method which should be competitively sustainable in the current market. Otherwise, we are developing in another direction which is not acceptable by any of the analytical chemists, then that method does not have value. So when we are looking or when we are developing any methodology, that should be having competitive value, market value, so that tomorrow anybody can adopt your technique in their premises. That is very important. So your method should be cost effective as well as easily transferable. That is very important aspect. Then it is part of easy use, so that any chemist, any scientist can easily adopt your method. If you are specifying some complicated protocols and that protocol cannot be easily adopted by any other chemist, then your method will lie in that same article. That method cannot be transferable. That is also another drawback of your method. So please look into that, how your method is easily adoptable by any other labs. Second thing is that it should be performance based. That is also very important. So these are the conditions which is used for pH PCB analysis by having the GC-HRMS system. These are the basically very generic conditions have been given by using electron impact ionization, and it's basically full scan data analysis with the 60,000 resolving power, and you can do that in full scan analysis. Somebody was asking just now a question, how that can be possible, how it can be differentiated full scan analysis with respect to single chord MS versus HRMS. So full scan point of view, you can get the total and chromatography remains same. When you are doing the extraction, you are applying in HRMS 5 ppm mass extraction window, whereas in triple chord or single chord you are applying that mass extraction window near about 700 to 900 ppm mass error. So that is the difference between these two. So you are extracting a lot of background noise also in case of triple chord or single chord, whereas you are filtering that background noise when you are putting 5 ppm mass extraction window, so that you are getting clear-cut signal, clear-cut picture of that particular peak and very limited or negligible noise. That is the difference, so that your purity of that signal is much higher level, and that's why you can easily achieve this mass error below 5 ppm. So you can see that above is the full scan. One just extract for soil sample, which is used for pH PCB extraction, and you can see that it's very complicated chromatograph. So each and every signal, if you wanted to click each and every point, then you will get some spectra. But parallelly, if you have a data processing method on the basis of first approach, that the target oriented, you can easily extract those signals with respect to your targeted approach, and you can see that very nice signal. But parallelly, if you wanted to see that untargeted approach, then you may follow that untargeted approach data processing software, which is called as a compound discoverer, where you can automatically software pick up that exact mass and it will try to match with the either NIST library or any other library available. Based upon that, you can get that identification of that particular mass, particular compound in your samples with the extracted ion chromatogram. Now, when you are looking for this full scan analysis, yes, everybody will say that yes, how it is a full scan analysis provide the best sensitivity. So this is an exceptional case in case of HRMS, where we are doing the full scan analysis and we are achieving the equal sensitivity as good as to your triple quad system. So when you are using triple quad system for MRM or SRM based approach and you are doing targeted quantitative approach, similar sensitivity you can achieve from the full scan analysis also by having the HRMS. Either OE 60,000 resolution or maybe 240,000 resolving power, both. Only difference is the resolving power and some additional feature difference, but you can able to achieve that even 60,000 resolving power system equal to your triple quad system. So for example, you can see that how that sensitivity or method detection limit has been achieved for pH PCB in case of soil, and you can see it's very low level, very I can say ultra trace level sensitivity has been demonstrated in case of soil, because soil is a very highly complex matrix to get that, and especially for GC-HRMS it is a very dirty matrix. When you are doing the extraction, you will get a lot of humic acid extraction which will damage your GC column as well as GC injector as well as detector site. So you need to be very precautious. So in that case, you should have to have proper cleanup for that sample, and then you can take the clean extract, especially for soil analysis. And if you are any times doing the soil analysis by using GC ECD, then your ECD will go on bad. ECD will not sustain for a long time, because humic acid will mask your ECD. So that is another challenge with respect to soil samples specifically. So you need to use a proper extraction method. So currently here we are using the Quechers extraction. Quechers is nothing but quick, easy, effective, rugged and robust SAIF method, which is acetonitrile based extraction method, and that is very much famous for the multi-component extraction. Either you can take a pH, PCB as environmental contaminants, as well as pesticide, antibiotics, mycotoxins also you can do extraction by following the Quechers method. So the Quechers method is very much famous sample preparation approach in the case of food segment, environment segment. So when you are looking for that sensitivity point of view, how this system provides you sensitivity and up to what level. So you can see that very nice chromatogram calibration curve you can get through this GC Orbitrap system, where you can see that very trace level and sensitivity you can achieve by following the internal standard approach as well as external standard approach, and you can get very nice linearity also as well as very low level detection limit. Here that achieving the detection limit at low level is a big challenge, because you can easily see that signal, but that signal should pass the mass accuracy criteria. As Sunil has presented, in that you need to pass that mass accuracy criteria within a plus minus 5 ppm, then only your results will be accepted for HRMS. Then you can go for quantitative approach. First, you should see that what is the identification criteria, where you are fulfilling that identification criteria based upon any performance criteria requirement or not. That is very important. So when we are doing the full scan analysis, we need to meet that criteria at least for 2 diagnostic ion within a 5 ppm mass accuracy. Then only we can go ahead for the identification and quantitation. So this is the linearity as a part of quantization approach, where you can see that all the compounds are giving you very nice 0.99 R square value with the stipulated calibration rate, and you can get that even percent RSD or response factor is also within acceptable criteria. So here you can see that one example has been given as a PCB as well as PAH as a part of metabolite. So you can see that how this information you can get from the HRMS. So left side you can see that this is extracted and chromatogram. So left side you can see that extracted and chromatogram, where you can nicely see that absolutely background noise level is very. It's okay. No. Background noise level is very nominal, or at least I can say it's a negligible. So you can expect very nice signal to noise ratio. But apart from quantitative approach, first thing you should see that qualitative approach. You can see the below table shows that what is the measured mass against your theoretical mass. So in that case, your mass accuracy plays very important role. You can see that you are achieving 0.2 ppm. As I mentioned that 5 ppm is a criteria we are normally following food analysis. So based upon that criteria, your mass accuracy gets very nominal, and it is very much acceptable in your results. And you can see that calculated concentration also through that calibration curve you can get automatically in that report template itself. So you can have that identification as well as quantitation data in one report template itself. Similarly, you can see that even though you have that trace level concentration of PAH as a metabolite, PAH 9-fluoro-eno, and you can see that where you can match the ion ratio criteria of 15%. Normally, criteria. Okay, thank you. So you can see that another example of the pH, where you can have the first quantitative ion is very nice, intense signal, but qualitative or confirming ion signal is very poor. It is just like in background noise. So, but you can match the RT point of view. Parallelly, you can get the very trace level calculated concentration with ion ratio variation is a 4.8%. So this in case of ion ratio for pH, PCB, in case of HRMS is not a mandatory. But if you can have the HRMS Orbitrap type system, you can get that ion ratio calculated in this software itself. That is an additional or maybe optional option you can get, and you should leverage that option regularly, specifically in difficult matters. Say for example, tomorrow you are doing the analysis of the tobacco or soil type samples. In that difficult matrix, your sample preparation is quite critical and lot of background noise is coming. So in that case, ion ratio will help you parallelly to get that clear identification of your molecules. Second thing, basically, when you are looking at the full scan versus deconvolution data, so when you are looking at the full scan dotted line, you cannot recognize which is your signal because it's everywhere, just like a zigzag type of nature you will observe, and it's very difficult to predict where is my exact signal. So when you are processing the same data through compound discover or any other trace finder type of the software, you can get the deconvolution pattern, and the software will automatically predict that based upon accurate mass where is your expected signal is there. So based upon that expected signal, you will get that extracted ion chromatogram in terms of the color combination. So that is basically called as the deconvolution of your data. So it will automatically making in simplified way, and you can easily recognize which is your exact mass with respect to the retention time, as well as you will get the calculated area.
then automatically software will recognize which is the compound related to what name. Either it will be common name or maybe IUPAC name. That nomenclature also given by the software, which is called a compound discoverer, or maybe trace finder also you can get this. Because nowadays this is a very much important with respect to commercial lab point of view, because they don't have much time to spend on the identification and confirmation by spending more time to really do that research activity. They need as long as faster reporting to share that report to their customer. So for that, this software is very much useful. Then, as I mentioned, this sample preparation, everything has been done for pH, PCB in soil sample matrix, but parallelly through screening, you can do this in that same extract pesticide also. You can do screening as a untargeted approach, or additional information you can pull out from that same data. If any pesticide or any other contaminants is already available in the soil, you can easily pull out that information. And this is the best example. You can see that this is one basically certified material which can gives you confidence about that matching with the NIST library and NIST score also. You can see that how that NIST score match. It's almost more than 80%, 90% NIST score. And that to NIST library is not the exact mass, accurate mass, it is a unique mass which you are using for single chord or triple chord system. Same library has been used here, and you can get that, but that algorithm has been given, and based upon that it will calculate on the result accurate mass, plus it will provide you the mass accuracy also. Second thing here, confirmation, as I mentioned, that basically lower is the chemical ionization spectra, above is that electron impact ionization spectra. So you can get that matching with respect to NIST library, and you will get parallelly how that matching happens. And there is now new approach is coming with that NIST also exact mass, and some of the compounds you can see that some targeted pesticide or some contaminant, environmental contaminants library is there which can give you exact matching with respect to exact mass also. And you will see that parallelly you will get the calculated molecular formula. Based upon that you can generate more and more confidence what type of structure we can get and what is the information of the compound. This is one approach when you are seeing electron impact ionization. But sometimes when you are doing the other unknown, then you need to go for the chemical ionization, and through chemical ionization you can generate the parent ion mass spectra with some adduct information, and then subsequently you can do that MSMS also, and you can get that parent ion which is giving you protonation as well as some M plus C2H5 adduct and even radical also. So based upon that you can try to correlate which is your target, and based upon that target you can get it further confirmatory through that structural interpretation of that same structure as a theoretical structural fragmentation pattern versus observed, and you can get that match fragmentation structure, and based upon that you can calculate it to get the calculated formula information also. This is another example, screening of the additional contaminants apart from pH, PCB. You can get that some pesticide also, some other pH which are available in that, which may not be your target in first objective, but you wanted to screen out that same sample for untargeted approach. You can get that information in this tabular form also through compound discovery. Second thing, basically when we are expecting multiple objective in one approach, then we need to sure about that what is the confidence level of the repeatability of the data. That is also one important aspect, how the data looks like robust. Because if we are saying that today I got that information but tomorrow I am not sure about that, that things should not happen. Today you got, at least you should get the continuous results to your colleagues or any other location also. Then only your data is considered as a robust data. It is not like having a lot of uncertainty. Okay, so robustness of your data is very much important. So here it has been given as a peak area percent RSD when you are doing the analysis of the 10, 20, 500 samples in that same system. how the data look like. So this is the variation you observe, and all the area, all the compound wise, you can see that almost close to 10 or below 10% area variation observed for almost 10 ppb level concentration, and it is very low level concentration. This is again cross check with the QC standard, certified standard, and this is also mandatory requirement when you are demonstrating any results. So you should see that with reference to QC or certified sample, you are monitoring the confidence with respect to mass accuracy. So how much mass accuracy you are achieving for the target or certified material. So that also gives you another level of confidence. So here you can see that you have given as a 1 ppm margin for your instrument by having the internal standard calibration approach, and if there is no internal standard, you are using as an external standard approach. Without internal standard application, you have the 3 ppm margin. So you can see that all results are within a 1 ppm margin, and you are getting very nice results. So that gives us confidence you are having the method, including your resources, all the configuration providing you confident results, and those are repeatable and rugged results. So that is the level of confidence you can show where you wanted to demonstrate your method is fit for purpose. Then this is one example for persistent organic pollutants in case of PHPCB soil. Similarly, you can do that same approach for other commodities also, like marine products. Similar application you can utilize PHPCB, even dioxin analysis. Dioxin requires some specific sample preparation. So that, and then chromatographic criteria is little bit different than PHPCB. Otherwise, the precaution also you need to take very cautiously, because that they require specific sample preparation, specific sample preparation area also. Similarly, there is also new contaminants came into the picture, basically PFAS. PFAS is also one emerging topic for the POPs, and they are analyzed by GC-Orbitrap as well as LC-Orbitrap or LC-MS triple quad also. So both as per your convenience, which machine you have, based upon that you can decide. But for PFAS analysis also, you need to have separate sample preparation area. Your sample preparation area should be much neat and clean. Otherwise, it will add on some contamination from your lab itself. So that you need to take a precaution. So for this, you can have the reference articles are available where you wanted to extend this work in your lab. Also, you can refer those articles and you can start this work in your lab with reference to your target matrix. Coming to other applications like basically food authenticity. So food authenticity also one of the emerging area, especially for food fraud concept point of view. And nobody has given that this food is a pure or impure, how we can define. So that perspective, we need to see that how we can leverage the HRMS facility to recognize this is my unadulterated food versus this is my adulterated food. So we can at least have the differentiation point of view, and we can find out which are the chemical marker which can give us idea about that food adulteration. So that approach you can easily achieve with this GC-Orbitrap or GC-HRMS techniques. So I am giving you one example in case of spice curve category. So you have seen that oregano, olive, thyme and marjoram, these are the 4 different types of the plant material we have used, and we have seen that oregano gets a lot of ingredients which are not supposed to in that as a pure material, but sometimes you will get that adulteration. So this is basically as a part of proof of concept point of view, this has been done. So all these 3 adulterant has mixed into oregano with the 10% of this adulteration point of view, because nobody is going to do that at 0.1 or 1% level adulteration. That is also we need to consider, and based upon that adulteration point of view, whether we can able to distinguish or not. That is very much important. And similarly, we did that earlier work for honey adulteration. Maybe you people have heard about 3 years back there was big incidents happens, and that honey adulteration, how to recognize that. So we did that same approach on LC-HRMS, and we were able to find out that marker compounds which are responsible to showcase that this chemical wise your sample is not pure form. Because of the chemical, something external material has been added into that. Either it may be rice syrup or any other corn syrup, something like have been included. So based upon that you can recognize some information, and then you can define that material is not pure. So similarly here is another spice and herb category. So oregano you can recognize whether it is a really pure or impure. If it is impure, then because of what reason. So you can have the chemical fingerprinting, and based upon that marker compound you can try to recognize because of either thyme or marjoram or olive it has been adulterated. So here you can see that as Sunil has mentioned about that during the basics of the instrument. So these are the techniques we can use, SPMA arrow, and then basically we have that similar GC-MS in full scan only, because here it's a typically untargeted approach work. So we cannot have the SRM or MRM based approach. So we need to do that full scan analysis only. And as I mentioned, we have kept that mass accuracy criteria, that is 1 ppm, which is very much important. Based upon that, we can able to recognize very faster and accurate our identification of molecular compounds. So this is the instrument configuration, SPMA arrow, and then these are the tools used in the SPMA arrow. So we can utilize those. These already Sunil has explained, I am not going to repeat. But where you wanted to recognize that full scan analysis through compound discoverer, so you can see that you have full scan acquisition in electron impact ionization as an untargeted approach. There is no any target, so you are setting up a full mass range depending upon your molecular ion range, and then you will acquire the data, and based upon that data you will have that basically purity or tentative identification based upon this library. Or maybe you wanted to go full-fledged as an untargeted approach, you can process the data by using compound discoverer, and based upon that you can utilize that what are the tentatively identified compound list. Parallelly, if you require statistical analysis also, you wanted to show that differentiation between the two sample or two different or three different samples, how they are different from each other, what are the chemical marker compound which are showing the clear distinguishing or differentiation from these samples, so that you require statistical analysis also. Then further you wanted to utilize that confirmation of that identified compound with respect to their MSMS pattern as well as parent ion confirmation. So already you have that EI spectrum, but you are doing again reacquisition of the chemical ionization either in positive polarity or negative polarity depending upon the nature of the analyte, and then you are reconfirming that as well as molecular weight confirmation with exact mass and mass error. You are giving that supplementary information to justify your identification is more and more precise and accurate. Then you have that second level structural elucidation also, where you are having chemical ionization MSMS spectra. With respect to that, in compound discovery you can get structural elucidation automatically, and then you can get that information as a part of report. So when you are looking that information, so as a part you can get the extracted ion chromatograph with respect to number of sample point of view, how much intensity or how much area available for the particular compound in particular sample point of view, you will get the overlapping based upon number of sample. Then you have that deconvolution MS spectra, and you are getting this spectrum matching with respect to your observed, and you can see that it's a perfectly matching, and this library it is showing as a unit mass, not exact mass, but it has algorithm supported to that test library which is giving you exact information. Then below is there you will get that confidence how much percent of the elemental composition, library match, HRF score is matched. So this is basically part of your measurement activity. So how you are justifying your results, so that's why you require all the information, and based upon that information you are generating confidence. Yes, I have identified camphene with respect to 98% confidence level, and then I have that basically this compound matched from the different source. So that information you can get from this compound discover data, and then further you can have that another dimension of that information. You can get the statistical differentiation between all 3 to 4 samples, and you can see that original is that close to your 0 value, but other 3 contamination or adulteration happens because of 10% addition. You can see all 3 are basically different level of or different corners of this chart. So you can see that how they are different, even trace level adulteration also you can recognize. Now why these are differentiating from each other? Because of chemical composition or any other factors there. This is purely based upon chemical composition, and which are those chemicals are responsible to show that differentiation. So you will get here chart, and through that chart you can find out that which are the marker compound I should focus to get the clear cut differentiation. Like this camphene, then allyl furoate, then methyl cinnamomate. So these type of some selected matrix wise selected marker compound, which you can also tomorrow you can set up this where you wanted to do that target oriented analysis. So these compounds you can monitor in either single order, triple order also, but you will get only for information related to only these 3 compounds. Whereas in HRMS you can get additional information. Then as a molecular ion conformation chemical ionization, you can see that above is your EI spectra. When you are doing the chemical ionization, you can have that protonation adduct as well as other chemical ionization point of view, multiple adduct information, which will provide you more and more authenticate information, where you can confidently say that yes, this molecule having this multiple adduct information as well as multiple adducts also passing within a 1 ppm mass accuracy. So that gives you really confidence about your identification and confirmation criteria, and then based upon that further you are having the MSM spectra for the parent ion in chemical ionization, and you can have that parallelly you can see all the fragment ion also passing the 5 ppm mass accuracy. That is the beauty of the arbitrage. So any HRMS you can see that MSM spectra, but you cannot give the guarantee about your mass accuracy. But here you can see that your fragment ion mass accuracy is also passing within a 5 ppm mass. So error. So that is a very important aspect. So and parallelly because of the fish coverage, you can see that your structural fragmentation pattern match with the observed fragment ion. So you can have that complete information. Any organic chemist or synthetic chemist, they can sit down and they can interpret very well to write down all the information. So with that I come to the conclusion. So basically GC arbitrage or LC arbitrage is the best tool for the authenticity of food product identification point of view. So not only this is only a spice category, same thing we just did it for one of the customer in Chennai, where we saw that one of the contaminated spice contaminated with a mycotoxin versus uncontaminated or pure spice chili powder. We have compared through this approach, and we can get clear-cut differentiation. Which are the contaminated with the mycotoxin, aflatoxin as well as ochratoxin. We get clear-cut separate pocket for this contaminated chili powder versus normal chili powder, which does not carry any contamination. So like that, you can use this tool and you can generate very nice information. So you are getting this mass accuracy because of high dissolving power. You are always expecting less than 1 ppm mass accuracy because that is a very important aspect. And it's not only showcasing for 1 or 2 samples, it is the consistency is also important. So you can expect that consistency from the arbitrary cost. So with that, I will stop here. If you have any question, I am happy to answer. Otherwise, I will formally hand over to next speaker.